Fluorochrome spillover is an important factor to consider when designing a panel, as this spillover can introduce spread and significantly impact your panel's resolution. Spillover is any overlapping signal captured by a secondary detector. There are three main sources of spillover. Let's explore them. The first occurs when two adjacent detectors from the same laser line both capture signal due to the spectral emission of the fluorochrome. Here's an example off the blue laser line. You can see spillover occurring when the right shoulder of the FITC emission spectra is captured in the PE detector. The second source of spillover is caused by residual donor fluorescence. This happens in tandem dyes, which are composed of a donor dye and an acceptor dye. Tandem dyes work by effectively transferring the emission fluorescence from the donor fluorochrome to the acceptor. If the energy transfer from the donor to the acceptor is incomplete, some residual donor fluorescence is emitted into the donor detector, creating spillover. In this example, we can see BV786, which uses BV421 as the donor, has some residual fluorescence emission into the BV421 detector. Finally, the third source of spillover occurs due to multiple laser excitation. This is also known as cross-laser spillover. While every fluorochrome excites best off a specific laser, there can also be excitation from a secondary laser. Here you can see that BV711 not only emits into its own detector when excited by the violet laser, but is also excited by the UV laser, emitting into the BUV737 detector. This is because both the BV711 and BUV737 detectors collect similar wavelengths. Now let's explore how one can manage spectral spillover. For co-express markers, spillover from adjacent detectors can be minimized by choosing fluorochromes that are spaced out across the same laser. For example, the emission spectra of FITC and BB700 do not overlap. To address residual donor fluorescence, avoid, if possible, assigning a tandem fluorochrome and its donor fluorochrome to co-express markers. Lastly, to address spillover due to cross-laser excitation, assign co-express markers to fluorochromes that have minimal overlap in cross-laser emission with other fluorochromes in your panel. Here you can see fluorochromes with minimal cross-laser spillover. With these strategies in mind, you can help minimize spillover when designing your panel. To learn more, visit bdbiosciences.com.